We're going to look at some more u substitution problems today involving trig. So our first example, we're going to do the antiderivative of 4 cosine of 4x plus 4. So the first thing I want to do is identify u. Okay? So when you have a trig function, you want to pick the part inside the trig function. So I'm going to pick just the 4x. Then my du, that's going to be the derivative of 4x, which is just 4. Okay. So this is the part with the u, so I'm going to write that first. Okay, so I've written this part. What I have left is the 4 dx, and remember the dx doesn't really matter. Okay. So we want this to match our du, and it does, so we can get rid of it. Okay, so now we're just doing the antiderivative of cosine. I'm going to rewrite my 4x as a u. Okay. Then I'm going to go look on my integral sheet, and I'm looking on this side because I'm doing the antiderivative. So what I have is the integral with cosine, so it's going to turn into sine. So I'm going to rewrite this as sine of u plus c, and then your last step is to always put the u back into the problem. Now for our second example, we've got antiderivative of 3x sine of x squared. Okay, so again, this is going to be the u. Okay, so whatever's inside the trig function is u. So I'm going to go ahead and write this part first. So that's sine of x squared. Now what I'm left with is the 3x. Okay. So I need to come over here and look at my du. So I'm going to take the derivative of x squared. That's 2x. So I need this part that's left over right here to match the 2x, and it doesn't. So what I'm going to do is you can take the number out in front. So you can always move the coefficient to the outside of the integral. I'm going to leave the x there. Okay. So this is what I need to match. Okay. So we want these two parts to match. So since this is missing a 2, I'm going to multiply it by 2. So since I multiplied by 2 on the inside, I have to divide by 2 on the outside. Okay, so now that we've matched the du, we can just get rid of this part. So we're doing 3/2 times the antiderivative of sine. Remember, this x squared is our u. So once you've gotten it to this part, you're just going to go to your integral sheet. You're going to look for the integral with sine in it. It's going to turn into negative cosine. So since we have a coefficient out in front here, it's going to turn into negative 3/2 cosine of u plus c. And then we're just going to put our x squared back in. So now on this next question, we have two trig functions. We have secant and tangent. Okay. So we've got x cubed times secant and times tangent of 1 minus x to the 4th. So if we look at what's inside the trig functions, it's the same thing. Okay, so we're still going to take that part and make it u. So again, I'm going to rewrite this part first. Okay, whichever part you pick that has the u in it, we're going to write that next to the integral. I'm going to go ahead and change both of these to u. Okay. Then I'm going to look at my du. So I'm going to take the derivative of this. The derivative of 1 is 0. The derivative of negative x to the 4th is negative 4x cubed. Okay, so this is what I want to match. Okay, so this part right here, we use this for u, so we're done with this. So I'm looking at what's left over. I'm always just going to write it over here to the right. Okay, So I need to make this match this. So it's missing a -4. So I'm going to multiply this part by -4. So on the outside, I need to divide by -4. Okay. Once I've made it match, I can ignore this part. Okay. Then I just want to go look on my integral sheet for the integral that has secant tangent. That's going to turn into secant. So I can rewrite this as -1/4 secant of u, and then we're going to go ahead and put our u back in, so you can do that all in one step if you want. So that will be -1/4 secant of 1 minus x to the 4th plus c. Okay, let's go ahead and look at just a couple more. We have 3 secant squared of 4x. So this time my trig function is squared, but since there's a trig function, I'm still just looking at what's inside the trig function. So I'm going to make u 4x. So this was the part that contains u. So I'm going to write that first. So that'll be cosecant squared. I'm going to go ahead and change my 4x to u. Okay. So the extra part I have is this 3. So to figure out what to do with it, I'm going to look at du. So I need to take the derivative of 4x. That's just going to be 4. Okay. So this is what I need to match, and it needs to be inside. Okay, so we always want to match what we get for du. So this 3 doesn't match, so I'm going to go ahead and move it to the outside. Okay, so I still need to multiply by 4 on the inside so that I can match this du. So since I'm multiplying by 4 here, I need to divide by 4 on the outside. Now that this matches, now I can get rid of it. So then I'm going to look at my integral sheet again, and I can see here's the cosecant squared. Well, that's going to turn into negative cotangent. So there's already a coefficient here, so we're going to make that a -3/4 cotangent of u. Okay. And then you can go ahead and change that u back to a 4x, and then you're always going to tack on a plus c. Let's look at one more example. So we have x secant squared of 8 minus 5x squared. So again, I'm going to make that part u. So I'm going to rewrite this integral as secant squared of u. Okay, so this is the extra part I have. This part was the part with the u. So I'm looking at what's left over. Okay. That's what I need to match du. So if I take the derivative of this, derivative of 8x is 0. The derivative of -5x squared is -10x. Okay. So all I have left over is just the x. I'm missing the -10. So I need to multiply this by a -10. So on the outside, I need to divide by -10. Okay. Then once you've matched this du, then you can just ignore it. Okay. So we're going to look at our integral for secant. So here's my integral with secant squared. That's going to turn into tangent. So I'll have -1/10 tangent of u. Okay, and then I'm going to go ahead and change that u back to the 8 minus 5x squared, and then tack on my plus c.